Welcome to Lesson 5 for Section 7 of the BJCP training program from the Brewers Anonymous Homebrew Club. We are flowing along with the subject of water. You can insert lame joke groans here. And in this lesson, we are discussing water hardness. When we are talking about water hardness, we are talking about the measurement of minerals dissolved in the water. What makes water defined as hard is our main question here. Well, in very basic terms, the concentration of certain minerals in our water is what constitutes the hardness, primarily calcium and magnesium. The more of these ions that are present, the harder the water. Now, these ions are not a natural structure of the water. Of course, we know that the natural structure of water is 2 hydrogen atoms and 1 oxygen atom, hence the well-known chemical code of H2O. These calcium and magnesium ions are ions that are basically living rent-free in the water, having moved into the water molecules as that water passed through their original neighborhoods of rock and soil. There's 2 common rock formations, limestone and dolomite, that are major sources of calcium and magnesium. Regions with one or both of these rock formations have naturally hard water. Now, not all hardness in water is the same. There's 2 types of water hardness, and they are temporary and permanent hardness. If the type of hardness in our water is temporary hardness, then the concentration of calcium and magnesium is coming predominantly from bicarbonate salts of calcium and magnesium. Left alone, the water won't change. However, when you boil it, as we do in brewing, the heat converts the calcium and magnesium into insoluble carbonates that settle out as a white, chalky substance that you very likely have heard of as limescale. Now, talking about permanent hardness in water, that hardness is caused by sulfate and chloride salts. These aren't as easy to remove, hence the descriptor of permanent. But it is possible to remove permanent hardness from water, typically through a water softener. So why do we care about this aspect of water? Like everything else we've talked about in this section, water hardness can impact your brew. Water hardness can raise the pH of your mash, and we learned in the pH lesson why maintaining a target pH is important. It can also react with compounds in the malt, specifically phosphates, leading to a haze in finished beer. Like everything we've discussed in this section so far, hardness impacts your brew, and knowing what it is so you can learn to adjust is another point of fine-tuning your brewing. And we're going to look at that a little further in the next lesson as we talk about modifying water. So if you're ready to head on over to the next lesson, I will see you there.